Welcome to part 7 of this Peatland ACTION mini-series on how to complete the spatial data template. In this episode, I'm going to show you how to undertake some self-QA, and this includes the 3 new self-QA tables in the measurement tables group of the template, alongside some other useful queries and plugins. Here you'll see a site where the mapping's been completed for application stage. Prior to submission, we recommend you undertake some self-QA. To help, 3 new autocomplete tables have been added into the measurement tables group in the spatial data template during the latest updates. These 3 tables all start with self-QA and sit below the tables which sum the totals of the features in the layers above. We've added a table to identify lengths or areas below 1 metre or 1 metre squared respectively. These are considered to be unrealistic to restore on the ground and likely the result of digitisation errors. The second table identifies any features which are missing site IDs, whilst the third table identifies features missing restoration techniques. These latter tables are important as this information will directly impact the totals provided within the other measurement tables, and features missing either IDs or techniques could result in an underestimation of the work required. To access any of these tables, just right-click and open Attribute Table, or alternatively select the layer and then click on the Attribute Table icon in the top toolbar. You'll see that all 3 tables have the same 3 columns: the site ID, type and count. The type column contains the names of some of the layers in the spatial tables group at the top of the template, and this helps you locate any issues which are flagged up. Likewise, the site ID column will be populated with a number corresponding to the site ID containing the error. This is mostly to help locate issues in larger applications which have been split into several subsites. Finally, the count column indicates how many times the check fails in that layer in that site. So for instance, we can see in the third self-QA table that there's 1 instance of a feature missing a restoration technique in the restoration lines layer. So in this case, you would need to open the attribute table for the restoration lines layer and sort the technique to identify the feature that has a null entry. Then investigate the feature in the geoplan and either apply the appropriate restoration technique based on the mapped erosion feature, or if it looks like the feature was created by accident, then delete it from the dataset. If you open the 3 self-QA tables and see that all of the site IDs are null and the counts are all 0, then you're on your way to submitting good quality spatial data. Another useful tool that we recommend using when undertaking self-QA is a topology checker. This can be found by this symbol in the toolbar. Alternatively, it can also be found in the Plugins Manage and Installed Plugins dialog box. You'll note that this is a core plugin in QGIS. Close the dialog box and click on the Topology Checker icon in the toolbar. This will open up the Topology Checker panel to the right-hand side. You'll see here that you have 3 icons: Validate All, Validate Extent and Configure. First, we want to select the Configure icon. This will bring up a new dialog box called Topology Rules Settings, and this is where you can create different rules for the layers which you've populated in your spatial data template. So select a layer which you've added restoration features to from the first drop-down menu to the left. I'll select the restoration lines layer for this example, and then from the second drop-down you can create a variety of rules. So select the rule you wish to create and then add it by clicking on the plus icon to the right. Go through and create rules for all of the layers that you have restoration features in. Where your feature count for the layer is greater than 1, it's also recommended to use the topology checker to check for duplicates. So here I'll create that rule for the lines layer by first selecting the restoration lines layer from the first drop-down, and then by selecting must not have duplicates from the second drop-down menu, and again using the plus icon to save the rule. Once you've created rules for all the relevant layers, you can press OK to close this dialog box and then choose to validate all or validate extent. We recommend using the validate all option to capture any issues across the full datasets. If I click this icon, you can see that 3 errors have been identified. All of these are in the restoration lines layer, and all of the errors highlighted are duplicates. The errors are also located in the geoplan via red highlights. The visibility of errors from the topology checker can be toggled on or off using the Show Errors on Canvas tick box in the bottom left-hand corner of the checker panel. You can use the information tool via the eye symbol in the toolbar to review the data within the duplicate features. Where the data is the same in both features, it can be safe to assume that the duplicate has been created in a digitisation error and can be removed. During the latest updates, we have introduced the secondary restoration technique to allow for multiple techniques to be listed under a single feature. Therefore, there's no reason to submit your spatial data with duplicates. To remove duplicates, open the processing toolbar via the cog symbol or the processing menu along the top. Search for duplicate and you will see a tool called Remove Duplicate Geometries appear under Vector General. Select this tool with a double click to open up a new dialog box. Select the input layer as the layer containing duplicates and hit Run. This will create a temporary scratch layer called Cleaned. The symbol to the right of the layer name indicates that it's a temporary layer and that the contents will not be saved anywhere once the project's been closed. Right-click and select Show Feature Counts. You can see that the 3 duplicates have been removed from this layer. So now it's time to copy the features in the cleaned temporary layer back into the template layer, but first we have to remove all of the existing features in the template layer. So open up the Restoration Lines attribute table and toggle editing mode on by clicking on the pencil icon. Select all of the features and delete them using the trash icon. Then open the attribute table of the cleaned layer and select all of the features before copying these using the copy symbol, the 2 pieces of paper overlaid by one another. Paste this data into the Restoration Lines template layer using the clipboard icon and save layer edits by clicking the floppy disk symbol. Close this box down and then you can remove the clean temporary scratch layer from the template. Looking back at the panels on the right, we can now shut down the processing toolbox and the identify results. If we validate all again, you'll see that there's no more errors identified. Whilst the Topology Checker is a useful tool to identify duplicates and invalid geometries, it isn't able to flag up any features that are missing geometries entirely. In order to identify any features that don't have geometries, you may have to use a query within the attribute tables. So open up the attribute table of a layer which you wish to query. As an example, I'll use the Restoration Lines layer. Toggle editing mode on by clicking the pencil icon and open the field calculator, which is accessible via the abacus symbol in the toolbar of the table. This will bring up a new window where you can add new or update existing columns. Note that if you have some features selected, the field calculator will default select the Only Update Selected Features box. Make sure that this first box is unticked if you want to update the full dataset, which in this case we do. Keep the Create New Field box ticked to the left-hand side and type length in the output field name. Adjust the output field type to decimal using the drop-down box and then go to the expression box below. You can use the middle panel to help create expressions, so if I go to the geometry and expand this group using the arrow to the left, you'll see a $ area expression. If you select this, then the function description appears to the right, and you can see that this expression returns the area of the current feature. Note that geometry-based expressions provide results in the units of the CRS, so in this case meters and meters squared. Scrolling down, you'll see a similar expression for the length. Select this and you can see that this returns the length of a feature. You can double-click and it will automatically be populated into the expression box. However, once you learn common expressions, you might find it quicker to type these directly in. Another useful expression is the is_valid (geometry) expression. Although note that this will return a true false and therefore the output field type should be set to Boolean. If after calculating the length or area you have features returning null values or a false Boolean value from an isValidGeometry query, then it's likely that this feature lacks geometry. Select the feature and zoom to it using the magnifying glass in the table toolbar. If you get an error message appear in the QGIS message bar saying that no extent could be determined, then delete this feature from the attribute table by clicking on the trash can icon whilst it's selected. Please note that the queries I have just illustrated do not automatically update for new or modified features, and therefore if you add new features or make changes to existing ones, it's recommended to rerun the query using the field calculator to update the existing column. If you've been copying and pasting data in from other sources, further information on how to do this is available in video 5, then there is a risk that the restricted values may have been overwritten. To easily check that the values in the restricted fields match those in the template, then you can go to the Vector toolbar in the top of the GIS window. From here, go to Analysis Tools and select the last option to List Unique Values. I'll demonstrate how I would check that the restoration technique and the material used complies with the template values for the restoration lines layer. So select the restoration lines layer as the input layer and then click on the ellipses to the right of the target fields box and tick the relevant columns before clicking OK. The results can be viewed in two ways, via the temporary scratch layer that's appeared in the layers panel to the left, named unique values, or by the HTML output file which will appear in the results panel to the right. So using the temporary scratch layer, open the attribute table and then also open up the attribute table for the restoration lines techniques in the lookup tables group below. It will probably be easy to spot any errors, as chances are you will have what appears to be the same restoration technique listed twice in the unique values, with one containing a slight modification to the template entry such as an additional space. If this is the case, open up the attribute table for the layer where the error has been identified and amend it to match the template. There are other videos in this Peatland Action mini-series including how to set up the spatial data template, how to add features to the different layers, and how to generate your restoration footprint. These can all be found on the Nature's Got Peatland Action webpage.